we just finished talking about related rates. Before that, we were talking about derivatives. We were talking about motion. And with motion, don't we have variables with t? Have we seen t's before? Yeah. What does t always stand for? Time. So before this section, if we were to be talking about time, we would be talking. You're working. I see you working. Okay. If we were talking before about time, we would probably be talking about like a of t, b of t, x of t. Question, with all of these that we talked about last year and then again this year, when we're talking about motion, what kind of motion are we talking about? How is everything moving? Huh? How is it moving? Right or left or? Up or down. Or up or down. You could only move right or left or up or down. Well, question, do we just move right or left or up or down? It'd be like a Pac-Man game. It's like instead of just going like we're used to, which is horizontally, or instead of moving, don't we sometimes move in curves, right? Especially on roads and stuff. We don't necessarily just move two-dimensionally. Or actually, this would be more like one-dimensionally. Now, we can go back in this motion because we can be going negatively or positively, right? But we can only go in a straight line. We can only go horizontally or vertically. We couldn't go both. We couldn't go both. So this was specifically, when we did motion before, we were only doing one-dimensional motion. Just in a straight line. We could only do one, that looks like a 2. We could only do one-dimensional or move one-dimensionally. It was only one-dimensional motion. However, that's not real life. Real life, you're moving two-dimensionally, well, actually, probably more like three-dimensionally. So, to account for that, parametric equations come into play. Not just moving along a straight line, not just moving one-dimensionally, but moving, well, we're not going to get too complicated, so we're just going to go to two-dimensional motion. Now, hold on. What's two-dimensional? A line is one-dimensional. A point is zero-dimensional. What's two-dimensional? Two-dimensional is a plane. Now, not three-dimensional, so not going up and down. We're not going like horizontally and vertically and up and down. So it's not three-dimensional, but just two-dimensional, which means we're not just going to be moving in a straight line. We're going to be moving along a plane. So we can have horizontal motion and vertical motion. We can have horizontal motion and vertical motion all at the same time. So your horizontal and vertical positions, back up here to the description, are changing with respect to time. Now, there are going to be 3 different main components that we talk about, and those are the 3 that are listed here in blue. So we have the path, the plane curve, another way of saying it, which is modeled by a function. Now, y equals f of x, okay, cool. So it's two-dimensional. We're not going three-dimensional. It's two-dimensional motion. It can be any function, curved or linear, diagonal. It can be any function. This is going to be the path that we're going on. But then as we move along this path, we're going to have horizontal change and we're going to have vertical change. So for instance, if we were doing, before we get to the next page example, if we were doing like old motion, which was just our x of t, if we were going right or left, now in parametric, if we were going right or left, this would make sense because right or left would be horizontal motion. So then x of t, I could have a rate as to how fast I was moving horizontally. But question, what would my vertical motion be if I'm just moving right to left and that's it? If I'm not moving vertically, then I'm not changing at all vertically. I shouldn't say y of t equals 0. I should say my dy dt equals 0. I'm not moving at all vertically. You can also say y equals 0, but I'm just moving horizontally. Okay, so that's why we just had that. Now, if I was moving up and down, technically it would be better if we had made it y of t instead. But it didn't make much difference back then because all we had to worry about was one function, and whatever that one function was, we just called him position. And it was only one-dimensional anyway, so I didn't have to worry about moving two directions. I just worried about one. Yeah.
Is there like a plan, draw a ball?
Plan. What?
Just fine. Just draw a ball.
Yeah.
That motion.
Yeah.
It's physics.
Yeah. So it's going to be much more practical. Let me show you an example. If you were to talk about the path, now we did this like in Algebra 1, Algebra 2, even pre-calculus, even in calculus, kind of. But we never dealt with motion that was along a curve. We never dealt with motion that was going anything other than just right, left, or just up, down. So now we're going to have motion that's going in a curve. So we have a path, and the path is shown by the function. Okay, so we have a quadratic, just a normal function. Ooh, we have a quadratic, just a normal function, right? We have our curved path, but it's not just a path. We have something moving at rates along that path. So we have an object that's being propelled into the air at an angle of 45 degrees. We have the initial velocity of the object, which is, we would think of it as initial velocity at an angle, right? But it has horizontal and vertical components like a vector. So it's a diagonal propulsion. However, we do have horizontal and vertical components. We can break it down, even though it's going, in a sense, diagonally, and then it's going to be changing position, which is what this little arrow means, the orientation of where it's going. We're going to talk about it as horizontal and vertical change, horizontal and vertical change, horizontal and vertical change. But not over a time interval so that it's approximate, but exact, so using derivatives. That's where we're going up to. So then, I wouldn't exactly, and I won't at any point expect you guys to come up with parametric equations. I think in physics you probably might have needed to. We're not going to be coming up with parametric equations. They're going to be given to us. But I want you to make sure that you realize the difference between these equations here and the types of equations that we would have talked about in motion before, because now when we're given x equals and y equals, what's happening is you have an object that's moving two-dimensionally, not just in a line anymore, but in a plane, right, in two-dimensional space. And it's moving along that plane. It's going a speed horizontally and a speed vertically. It's going to have two different rates. And so these equations are going to depend on how fast it's going. So these are going to change. They're going to have to either give you a t. Actually, we can keep on going from here. I just wanted you to see the difference between these three different elements. So I have the path. I didn't need to magnify. I have the path. I have horizontal position. And I have vertical position. So the path is just going to be f of x. Horizontal position, vertical position is how it's changing horizontally and vertically. Okay? So here's just a visual of it. I have my path. But I also have how fast or how it's moving horizontally. I shouldn't say how fast because we haven't taken the rate yet. And how it's moving vertically with respect to time. Okay? With that, we're going to have to pick up Monday. I wouldn't have gone in as much detail if we hadn't seen it in pre-calculus. I'm going to put these notes up online. Homework number 12, which is 10.2 and 10.3, starts at pre-cal. So guys, look real quick. 10.2 and 10.3, we're going to cover pre-cal just a little bit. But here's what I want you guys to do. Section 10.2, the homework for section 10.2 is pre-cal review. I want you to read section 10.2. If you took summer parametric equations, wasn't in the class, read 10.2. We're going to quickly look at that on Monday, but then we're going to derivatives of parametric in 10.3 on Monday as soon as we can, okay? So homework, read 10.2. Try to do homework on 10.2. If you want to, though, save a few questions for me on Monday to answer. All right, okay, I'm done. We'll catch up. It's the pre-cal, huh? Hopefully we at least have an idea of what's different with these teams. not one dimension, it's two. Didn't use that. They should have given me a double.